Hey guys, part two of the mini lesson series here. This is 8.4, adding, subtracting, and or a better word to use is combining. Okay, and multiplying radical expressions. So we only have a couple of learning objectives today. We're going to combine radical expressions, and that's by CLT, combine like terms. Remember, it's better than a BLT, right? Okay. Multiply radical expressions, classic multiplication, distribution. As a reminder of the sum of a, well, sorry, I'm just a little tired right now. But if just as a reminder, if we're doing a perfect square of two things, we have a pattern, right? And the pattern's listed here, and I'm not really sure if you remember it or not, but I left it there just in case. So we'll go through some examples here. Number one says add or subtract as indicated. Now, see, I hate those words. It should be combine as indicated. It should just make it simple, because we all know that if we're subtracting, we're adding negatives. And we're going to assume that they're all positive. So what did I do first? I took 63, factored it out, and realized that I have the square root of 9 times 7. I then did what? Took the square root of 9 times the square root of 7 minus the square root of 7 right here, right? And I took the square root of what? 9, because we all know that's 3, right? And in this case, I want you to think something to the effect of 3x minus x, where x is the square root of 7. You see that? So we have 3 square roots of 7 minus 1 square root of 7, which gives us 2 square roots of 7. Okay. Next problem, 7 times the cubed root of x cubed y to the 13th plus 5xy cubed root of 8y to the 10th. So in the first part, as you can see, all I did was rewrite it. Nothing big. Then I decided to do what? Change them into rational exponents, right? So rat x, okay? And the reason why is because it's kind of nice to be able to work with. Much better sometimes than the radicals, just because they remind you of what you have to take out and everything, and sometimes the fractions are a little easier to work with. So then, from this step, we did that sort of distribution move, which we're not supposed to call it, but it's really not distribution, but it reminds you of a way to just kind of think about it, that we're multiplying or sort of raising everything to that power. And you'll see that now, when we do that, we get x to the 3/3 right here, y to the 13/3, and over here we get 8 to the 1/3, which we know is 2, because that's really the cubed root of 8, and y to the 10th over 3, right? So now I just started to break them down again, just like I did in a previous example from one of our other videos. What we can see here is that x to the 3/3, the one that I have pointed right here again, is really just x, so I pulled that one x out. Then I broke the y's from the 13/3 into a product of two factors, and what I have here is y to the 12/3, right? Well, 12 divided by 3 is what? 4. So that means I can actually take a y to the 4th out. And then what's left over is y to the cubed root. I missed one thing, so I'll put that there. The cubed root of y. And I missed it here too. Little accidents happen. So in the same instance, I did the same thing over on the other side. The cubed root of 8 is 2. And then I broke down y again from 10/3 into 9/3 and 1/3, right? Because when you multiply like bases, you add the exponents. Remember, when you have a to the nth power times a to the mth power, you're going to get a to the n times m power. So, whoops. A to the, I'm really tired. To the n plus m power. I should have just restarted this whole thing, but that's okay. Real tired. Anyway, remember, when they're like bases, you add the exponents. So then what we did was I put everything back into radical form and simplified. You can see that I combined the y and the y cubed to give me y to the fourth. I still have the cubed root of y on both. So now that they have the same beast, right? They're the same beast. It's basically like saying 7, big junk plus 10 big junk is equal to 17 junk. And that's exactly what we did. We just took what we had, added them together, because we're thinking about this whole thing, right? We're thinking about this whole thing as junk. So we can add apples to apples and oranges to oranges. And in this case, we get 17xy to the fourth cubed root of y. Now I rewrote it separating by the quotient rule, right? We're using the square root, so the square root of 20 over the square root of x squared, which we're looking at here, plus the square root of 5 over the square root of 4x to the fourth. So I did what? Used the product rule, separated it out, found the factors. We know the square root, 4 times 5 is 20, right? So the square root of 4 is what? 2. And the square root of 5 is square root of 5. We're not going to do anything with that part just yet, but then take a look. We separated the denominator here as the square root of 4 times the square root of x squared. Now, we know the square root of x squared really should be the absolute value of x, but because we're working with all positives, we're just going to assume that it's all positive. So from each step, you can now clearly see where I got the 2 from and where I got the x from, right? And the radical 5 just stayed square root of 5, right? Square root of 5 in the top, square root of 4, 2, and x. Now I had to make what? We had to make common denominators, right? So the common denominator was 2x, so all I had to do was multiply this beast right here by 2 over 2. And that's exactly what I did. 2 times 2 is 4, and 2 times x is 2x. And when we come to the solution and when we actually combine them, remember, once they have the same denominators, we're just carrying out the operation in the numerator, right? So 4 of something plus 1 of something is 5 of something over 2x, or in this case, 5 square root of 5 over 2x. All right. Number 2, multiply, then simplify, if possible. And again, they're all positive. So again, all I did was what? Use the distribution property. So square root of 6 times the square root of 5, the square root of 6 times the square root of 7, right here. So we can't factor anything out, right? Because 6 is 2 and 3, and we need a pair of something, and we only have a 5, so we just leave it as the square root of 30. And the same thing is with 6 again. 7's prime, and 2 and 3 are prime, so it's just going to be the square root of 30 plus the square root of 42. I did this second one here, G, by distribution as well. So I'll use the orange again. So I took this little beastie right there, right? And I multiplied it by that beastie. And I got this little beastie here. And then I took this little beastie and multiplied it by that little beastie. And I get this little beastie here. And then I better use another color, finally. I use this, and went boop, right? And boop, shoo, boop. Then all I did was start to combine, do the basic products. 5 times 6 is 30. Square root of 3 times the square root of 3 is really the square root of 9, but we know that's 3. Remember, when you multiply any kind of square root of 3 times the square root of 3, you're just going to end up getting 3 back. So just as a little reminder. All I did then was combine like terms after the simplification and crunch down the numbers. How did I get 54? Well, 90 minus 36. Well, where did I get the 90 from? 3 times 90. Oh, sorry, 3 times 30. So 90 minus 36, 54. And then a negative 20 and a positive 54 root 3's gives me 34 root 3. All right. Here's one of our special ones. I did it out. I'm still using orange. I did it out using our binomial here that we're squaring. And remember our little expanded. So here's the binomial squared, and this right here is our expanded version. I then told you what A and B was, and then I did what? Starts with an S. Right? So once I did that, I just carried things out. The square root and a square cancel each other out, leaving x minus 4. 3 times 2 is 6, and 3 squared is 9. Combine like terms, and you have your answer. The other way is the classic multiplication, and I set it up a little bit weird, like everybody thinks. But remember, this is just 2-digit numbers that we're technically multiplying. So I did the square root of x minus 4 times the square root of x minus 4, which you can see down here and here. And then I did the square root of x minus 4 times 3, and I got 3 root x minus 4. Same thing on the other side in blue, and the last one in brown. And when you combine all of them, remember we're multiplying, right? We're multiplying, right? And then we add. So just classic multiplication. And that'll do it for now. Wishing everybody well, and hoping you have a good day.